Welcome to Pocket Portal Academy. We provide hands-on do-it-yourself short sessions on data science, machine and deep learning industry use case studies using tools like Excel, SPSS, Orange, PSPP, and Statcraft.
So basically this is a bank sheet which gives you the names of each of the banks. They are public sector banks and private sector banks, and it gives you two sets of columns. One is the return on assets, ROA, and the other is return on equity, ROE, for 3 years from 2018 to 2016. Usually we always take Excel first into as time series and then subsequent series, as you already know. Now what is it that we are basically clearly seeing here? There are two factors here. First factor is the bank, the second factor is the year. Because what we see, we want to see what would be the null hypothesis. Let's say ROA or ROE are the same for each bank. And what is the second null hypothesis? ROA and ROE are similar across the years. So clearly it is a cross tab. On the rows we are taking banks, on the columns we are taking years, and the values are the ROA and ROE. ROA and ROE are nothing but dependent variables here, which is not under our control, but bank is under our control and the years that we take are under our control. So clearly they are the independent variables. Independent variables, or we can call them as the two factors. Now in the rows you can see that I have not done any factoring as of now. I'm just taking each bank as it is. As each entry of a row is a bank. But if you come to this second sheet, sectors, here you will see that we have actually done a sub-factor among the banks, and that is on the base of sectors. The sector I mean a public sector and a private sector. So there are 20 entries here in this bank list. These are list of 20 banks based on their return of assets and equity. And 3 years are taken 2016 to 18. 10 banks are from public sector and 10 banks are from private sector. In this, the second sheet sector, I have actually further divided the banks into a sub-factor for the public sector banks and private sector banks. I have taken 10 as public sector and 10 as private sector. So because there is a sub-factoring, so I will have here 3 null hypotheses, as you can see. The first null hypothesis will say the returns are similar across the banks, because in the rows there are banks. The second null hypothesis will say the returns are similar across the years, because in the column there are years. The third null hypothesis will be say returns are similar across the sectors. And what are the sectors? Public and private. So clearly we are having 3 null hypotheses, because the third one, which is the third, actually takes into account the combination of both banks and the number of years. So now let us go and look at this bank's data set again, and clearly see that in the bank's data set we are only seeing banks and years. Because bank has one observation per row, we will use without replication, because there is no replication here. There is no sub-factors here. So what you do is that you go to data analysis and you choose something, you choose Anova two-factor without replication, because there are no sub-factors, and then you have to choose this entire thing. Let's say we are doing ROA, because you have to change, do it on this rows as well as column. You have to see the impact of rows and impact of column on the return of assets and return on equity. So let's go to data. Go to data This will be Anova 2-factor without replication. Input range is this, labels 0.05, and this is what you get.
Yes.
Okay. You can see, scroll down, and you will get the Anova tables also. Now, let us briefly analyze what exactly are these tables doing here. The first one is basically it gives you table summary statistics. First table gives you the summary statistics, the second table gives you the Anova calculations. Now, this actually gives you the summary statistics of all the banks as well as all the years. So if you see the summary statistics, BOB count is 3. Why? Go back to the banks. BOB is counted 3. I am taking BOB is a bank is a row. So 3 years in a row. So BOB in 2018, BOB in 2017, Bank of Baroda in 2015. So each of the banks count is 3 because it is counted for 3 years. Then obviously I will take the sum of the ROA, the average of the ROA, and the variance of the ROA. When I am taking the variance of the BOB, it is what is the variance across the years I am taking in BOB. Here, what is the variance across the years in the BOB? Similarly, I take for every bank the count, the sum, the average, and the variance. Now you come to Anova. To this part, which is basically taking the columns. ROA 18, ROA 17, because we are having 2 factors. The first is basically the rows. We will call it the rows and columns. So just remember here the rows are banks and the columns are years. And there are 2 null hypotheses. First null hypothesis is pertaining to the impact of rows, which is banks on ROA. And null means there is no impact. The second pertains to the impact of years on ROA. And null means there is no impact across the years on ROA. They are similar. Is the null hypothesis clear why we are taking rows and columns?
Yes, yes.
Okay, great. So when you see here ROA 18, 17, 16, now we are basically taking the columns summary statistics. And if you take the column summary statistics, as is very obvious, in each of this column, there are 20 observations. Because there are 20 banks. So now it is doing the summary statistics of the column, 20 entries. First column, it will take the average. Second column, it will take the average. First and third column, it will take the average. Sorry, the first column average, second column average, third column average. And this is the first column variance, second column variance, third column variance. This is what is first column sum, second column sum, third column sum. Column 1 is 218, column 2 is 2019, column 2 is 2020. This is the variance of 2018, variance of 2019, variance of 2020. So this is as far as summary statistics is concerned. Now this one is important. What is basically the Anova statistics here? Now let us come to the interpretation of Anova statistics. And if you remember what you are going to do in Anova, the sum of squares is the first. When we talk about rows is nothing but banks. When we talk about columns, and there are 20 banks. When we talk about columns, we are nothing but we're talking about basically the years. Three years are there, and there is something which is called an error. Error is basically there always will be an error in the variance in the two groups because something can happen because of the chance. And whenever you are taking a 2 Anova, it is equivalent to a t-test, sample t-test with the treatment. You say the treatment can be the number of years because the treatment meted out because of inflation and other things would be different. So that's a treatment. So there are a lot of things that can happen because of chance, because you are giving a pill and you are giving a actual pill and a sugar pill. But a person who is ill, he can have very high immunity and he gets cured. Similarly, a person who is given a sugar pill actually can fall ill because of some other reasons, not because of that disease, but he has some underlying other comorbidities. So there are certain chance errors which can happen. So that error is because of that, and that cannot be neglected. In a example of Anova, the variance is a very, very fundamental thing. These are unexplained random errors. So we take one, it also calculates the error. So now, when we look at the sum of squares, let us calculate the first one, rows. Here the sum of squares of the rows is this one, and the degrees of freedom is 19. Because there are 20 rows, and the n is 20, 20 observations, degrees of freedom is n minus 1, which is 19. So what is the mean sum of squares? The mean sum of squares is nothing but sum of squares divided by degrees of freedom. So if I just calculate this thing, what is the mean sum of squares of rows? It is sum of squares divided by degrees of freedom. You will get 0.00032. Similarly, if I see the mean sum of squares of the columns, which is basically years, it is nothing but sum of squares of the columns divided by degrees of freedom, which is 2. So this is coming 0.0011. Now, why this degrees of freedom is 2 here? Why this is 2?
Because the degrees of freedom. Because we have three,
Look at this. What is this?
three columns: ROA 16, 17, 18.
What is a column?
ROA 16, 17, 18.
No, our column is simply years.
Yes.
2018, 2017, 18. How many columns are there?
3 columns, sir.
So what will the degrees of freedom here?
N minus 1, so 3 minus 1, 2.
How many rows are there?
Rows are, sir, 20 rows.
Banks.
Yes.
What is the degrees of freedom?
20 minus 1, which is 19 degrees of freedom, sir.
Absolutely. And what is the total degrees of freedom when you take rows and column together?
It becomes 60.
How many observations are there total for rows and columns taken together?
60 observations, sir.
3 columns and 20 rows. 3 into 20 is 60. What is the degrees of freedom total?
6 is 1. So 59. Sorry.
Okay. So now we actually also have something called an error.
Yes.
Mean sum of squares. So if you take the mean sum of square of error, this is again sum of square of error divided by degrees of freedom. So you will get this mean sum of squares of error. Now that's fine. Now let's calculate the f value, because this is nothing but the f calculated. F calculated. There is nothing but f calculated. Now what is this f calculated? F calculated is nothing but
Mean square divided by degrees of freedom.
this is mean sum of square. F calculated is mean sum of square divided by the error. That is what is F calculated. So here, when I take the rows is bank. What is the F calculated of rows? What is the F calculated of banks? It is the mean sum of square divided by the error.
Yeah.
what will be the answer? 11.924444 is the F calculated, and this will be the F calculated for rows, which is nothing but banks. What is the F calculated for columns? Same concept.
Yes.
Which will be the mean sum of square of the years divided by the error. So this will be 4.888 F calculated of columns, which is years. Now we'll go back to the same fundamental analysis. What is the fundamental analysis? F calculated of rows. F calculated of rows is more than critical of 1 point. Critical is a tabulated value. So what do I do then? What do I do?
So it means, sir, for the rows we have to reject the null hypothesis. We have
I
to
reject null hypothesis for rows, which is banks. Now for the bank, F calculated column. How much is this? 4.88. And how much is F critical? What we do here? I think you're muted.
Sir, can you hear me, sir?
Yeah, now I can hear you.
So I'm saying, sir, here also the F calculated value for columns is more than F critical. So we will reject the null hypothesis for columns.
Reject HO again for column.
Yeah.
Now what does it mean reject HO for rows?
So it means, sir, it means that their means are not equal. So all these banks are uh, all these banks are
Average ROA for each bank is not similar. Which actually what Anova is telling you, at least one bank is not the same. I mean, even if one bank is not the same, all will be rejected. There are, I mean, how many groups are there? How many entries are there? 20 entries. Even if one is not similar, Anova will be rejected. So average ROA for each bank is not similar. Similarly, what will be the analysis here for the column?
so average ROA for years are not similar.
Not similar. So, you know, the analysis becomes very simple. It was a very complicated data sheet. Now you come back to banks again, and now you do the same for ROE. Just do it.
Yes, sir.
Just do it for ROE.
Yes, sir, I am doing.
Without replication.
Okay. Yes, sir.
Are you getting something like this?
Yes, sir. See.
Okay, fine. Now again, this is all summary statistics because there are 20 entries. Bank of Baroda is counted 3. Count is 3 for 3 years. Sum of the 3 years is this. Average of the 3 years is this. And the variance of the 3 years is this. This is as far as the row summary statistics. Now these are the column summary statistics. The count of the column is 20. These are the years. The summary statistics average sum of 2018 is this, average of 2018 is this, and variance in the 2018 is this. This is as far as the summary statistics of rows and columns are concerned. Now analyze this.
So
we need not go through the F calculation again, it's the same formula. It's already given to you. So what will be the analysis here?
so F
Rows. First of all, take rows. What is rows?
rows are our banks.
Very good. What do we do for the banks?
So for rows, for banks, the F calculated is more than F critical, so we will reject the null hypothesis and we will accept the alternate hypothesis. So
And what about the columns?
columns
What
means
is column?
columns are years 16, 17 and 2018. These two years are columns. So columns also F calculated value is more than F critical, so we will reject the null hypothesis and we will accept the alternate hypothesis.
Reject HO. Reject HO. So how will you frame? What is HO1? So what will be the this thing here? Average ROE
Yes.
of banks are not similar. Average ROE years are not. Now, this is very simple. This is we have got a good analysis so far. Two-factor Anova without replication. We have taken two factors. One is the banks, the other is the years. Now we want to find out the impact of sector. Impact of sector and year on ROA. So I have taken first analysis was about bank and the years. Two factors for bank and the years. So far we have taken the analysis of banks as one factor and year as the second factor. Now I want to do an analysis of sector and the year. So go to the sectors. I want to do a factor of sector and year. Factor 1 year. Factor 2 year. So when I do a analysis of factor and year, it becomes very clear to me that this is further subdivided into sub-factors. Public and private. So my sector is further divided into sub-factor, which is public and private, as you can see. 10 banks in public and 10 banks in private. So this actually becomes a case of two-factor Anova with replication. With replication because of a concept called as sub-factoring of one of the factors. Is this clear why we are taking sub-factors? Why we are taking two-way Anova with replication? Because there is a sub-factor. When I take first in the case of banks, I took bank and year. Now I am taking sector and year. But when I look at sector and year, I look at they're already divided into two sub-factors. Yes. So in this case, I will have three null hypotheses. HO1, HO2, and HO3. What will be my HO1?
HO1 will be
and HO1 is basically what will be HO1?
Public sector and private sector both having the same ROA.
My HO1, basically there are three factors. One is a bank, one is a year, one is a sub-factor. So when I look at HO, I will simply say returns across returns are similar across the banks. HO2 are returns are similar for the years. Returns are similar for sectors and years. When I take HO1, I will not take banks. Here it is sectors. Okay. So my null hypothesis one is returns are similar for the sectors, both the sectors, and sectors are also taken in row. This is basically sector. HO2 returns are similar for the years, and HO3 returns are similar for both sectors and years. Here we take the impact of both rows and columns. This is called interaction. So when I do a data analysis, I will do the same thing. I will now select this as the data. This becomes my data. So let me do a data analysis of ROM and check the three and HO. Go to data analysis. I will take two-factor with replication, and I have to choose public and private because that's where the sector name will come. Then it says rows per sample. How many entries are there per sub-factor? There are 10 public sector banks and 10 private sector banks. So there are 10 entries per sub-factor. 10 sub-samples in this. 10 entries. Rows per sample. Each sample here is a sector. So when Excel is saying rows per sample, in the final answer it will give you sample. Sample for me is a sector. Are you getting this answer?
Yes, sir.
Okay. Now let me go down here. So first sheet as usual will remain the same. It will be basically your summary statistics. Now if you see here in the summary statistics, there will be a column called public. There is a column called private. These are the sub-factors, and there are basically total. So there are count is basically when you take the count of public. Each there are 3 years, 2006, 18, 17, and 16. So there are 10 counts because the sample there are 10 public sector banks and 10 private sector banks. So across the years in public sector banks in 2018, this is the total sum. Public sector bank 2017, this is the sum, and 2016 this is the sum. So the average of 2018 is this, average of 2017, 2016, and variance is this. So this is variance of public sector banks in 2018, variance of public sector in 2017, variance of public sector in 2016. Similarly, we do the summary statistics of private, and then we actually take the total, because total there are 20 observations, and then when we take the total, why we take the total? Because we have to take basically total impact also. So we take the total, and we get this as total. Now let us come to the Anova factor here. Anova analysis. What you see in the Anova analysis?
Now we have three. One more row is added for interaction.
What is the row here?
Row here is public sector and private sector.
This is nothing but sector.
Yes.
What is column here?
Columns are years.
Now in this, there is another column called interaction. We will study that in Anova. Interaction is when you take the combined effect of rows and column. First you take the effect of rows, then you take the effect of column, and then you take the combined effect of rows and column. So what is the F calculated in sample, which is sector 74? So what do I do here?
We will reject the null hypothesis.
Reject H. What do I do here? Columns.
We will accept the null hypothesis this time.
Accept the null hypothesis. What do I do here? Interaction, which is the combined effect.
Accept the null.
You are getting pretty good in analysis. Now, can you just frame it in words? What does it mean?
Private sector, the return for private sectors and
We will, because it is actually calculating the mu, so we say the average ROA based on sectors is not similar. That means that the average ROA given by public sector is different than given by the private sector. Here the alternative is correct. So they are not same. The return on assets by public sector banks is different from that of private sector banks. Okay.
yes.
And what do we write here?
So average ROA based on year are similar.
Based on year are similar. Is this what I had got in this analysis also? Here average ROA for years are not similar.
Yes.
And here I am getting average ROA based on years are similar. And what is the interaction when I take the combined effect?
Years and sectors. Average ROA based on years and sectors are similar.
Combined effect of sectors and years are what?
Similar.
So when you had a very complex data sheet like this, and you just had a sample of 20, and there are hundreds of banks, you are very effectively trying to do the population hypothesis of the entire country banks just by looking the ROA and ROE here. Now do the same thing for ROE. So Anova two-factor with replication.
Yes.
Suppose for sample 10, alpha level 0.05. Okay. So again, it gives you a summary statistics. It gives you the count of every year, and then it gives you the total count. Let's come to the Anova table. What do you do here?
In the sectors means for the first one, we will reject the null hypothesis again. Our average ROE across the sectors are not similar. average ROE across the years again are not similar.
Let's just take the rows first. First, what is the row?
Row is sector.
So it shows here is a sample. What is the sample? It is a sector. And what is the analysis here? F calculated is 60, F critical is 4. So what do I do?
Reject the null hypothesis.
Reject H, which means what?
Which means average ROE across sector are not similar.
Then I take column. What is the column here?
Yes, sir.
What is the F factor here? F calculated is 3.4. F critical is 3.16.
So we will reject H naught.
Which means
ROE across year are not similar.
what is interaction?
Interactions are combined effect of sector and year. But here also,
What I do here?
we again reject the null hypothesis as
Which
reject
means that
which means average ROE based on
average ROE
is
combined effect and years are not similar. Now, if you look at one of the sheets where we had done the ROE earlier, which is sheet 2, I think, there also we had done the same thing. Average ROE of banks are not similar, average ROE of years are not similar. So here I had done for the banks, and I just wanted to go one step further by taking a sub factor of the banks, and that would be my sectors, and then checking whether the sectors are similar or not. And now I am finding that this is what is the combined output. So when you are taking a Anova kind of exercise, it is in short, it actually gives you